Here, I've built my 4-bit universal register. So on the left, we have our select inputs, our controllers, our input, our 4 bits to be registered, our in right and in left. And then on the bottom, we have our clock, enable, set, and clear. And on the right, we have our outputs. So if I put 1, 0, 1, 1, send it to clock, I load it, put it into 1, 1, which is load. And now our register is outputting our input. And if we go to 0, 0, no change. Give it a clock cycle, there's no change. And then if we go to shift left, and we have zeros on the left, then everything shifts left 1. But if I change the in left to 1, then 1s come. Alright. And then if I go shift right, then our bits will shift right. And if I change the in right to 0, or to 1, then we'll get 1s coming in. So inside the device symbol, we have our full circuit here, made of 4 muxes and 4 D flip-flops. And so here are our select pins, and we have the set, clock, and clear, the same for all the flip-flops, as well as enable and the selects for all the muxes. When we receive 0, 0, we're in no change mode, so that'll be Q0 on each of the muxes, or not Q0, sorry, D0 on each of the muxes here. And so you can see that the corresponding output just goes right back into the input. And when we have 1, 0, we're getting a left shift, and that will be D1. So D1 receives Q1, the value from our bottom here, and D1 over here receives Q2. So each value just moves to the left. And then at the bottom, that's where our in right comes in. All goes into D1. When we have 0, 1, that will be shift right. Yeah. And so our in left comes in there, because Q2 will then go into D1. Sorry, Q0 to D2, Q1 goes down to this one, and then Q2 goes to this one. And lastly, when the select pins input 1, 1, we are in load mode, which is just taking the input from 0 through 3, and it goes directly into the muxes, and therefore gets stored in our flip-flops. Now to define register, a register is a device holding one or more flip-flops, and these flip-flops are there to store memory. So the register is there just to store data, whether that's a binary number, 1001 or something that's supposed to go together, or if they're separate instructions. A shift register is essentially the same thing. It's a register there to hold data through flip-flops, except it has the ability to shift the data that it holds, either right or left, and that'll essentially divide or multiply its data by 2. When a register is parallel loaded, such as with this register, all of the inputs are sent in all at once basically, and all that data is stored simultaneously. So the clock is set up connected to each of the flip-flops, and all of them update instantaneously. When a register is serial loaded, the input is put in just 1 bit at a time, and it takes 1 clock cycle to store 1 bit. So if this register happened to be serial loaded, it would take 4 clock cycles to load each of the flip-flops with their data.